Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use electronegativities to classify bonds. So again, in this video, as in a previous video, I'm going to show you how you can use electronegativities, or more specifically the electronegativity differences, to identify whether the bond between two atoms is going to be nonpolar covalent, polar covalent, or ionic. So here I have the electronegativity differences here. So here we're going to use this range here. You might have a little bit of a different range from your textbook or your professor or teacher. Just follow what they say. But here I'm going to use this range. So if the electronegativity difference is less than 0.4, then we're going to consider that a nonpolar covalent bond. If the electronegativity difference between the two atoms is between zero point 0.4 and 1.7, we'll include that as a polar covalent bond. And if the electronegativity difference is greater than 1.7, we'll consider that an ionic bond, unless, of course, the bond is between a metal and a nonmetal. Then we'll make that an ionic bond. So some textbooks will have a slightly different one, where a different division of the ranges, if you will. So some might say less than 0.5 here. And then for this range, it would be 0.5 to 2. So if it's in between zero point 0.4 and, or I'm sorry, 0.5 and 0.2, then it would be polar covalent. And then if it was above 0.2, if the electronegativity difference was above 0.2, they would consider that ionic. So that might be preferable for your class, or your textbook might use that. So let's go ahead and apply this to our problems here. So for A, we have nitrogen bond to hydrogen. So we can kind of look at this and say, okay, we have two nonmetals. So we would expect this to be a covalent bond, not ionic, because ionic requires a metal and a nonmetal, okay, because there's going to be that complete transfer of an electron. Here we have two nonmetals, so we would expect a covalent bond. And then so now we have to kind of figure out, is this going to be a polar covalent bond or a non-polar covalent bond? And you can see, based on, if you know the periodic trends for electronegativity, you can see that the farther apart they are, the more the difference in the electronegativity, and so the more the likelihood it'll be not a polar covalent bond rather than a non-polar covalent bond. So here you can see that nitrogen and hydrogen are going to be far apart on the periodic table. So we would expect this to be a polar covalent bond. But let's look at the electronegativities and verify based on the electronegativity difference. Okay, so for nitrogen, if we look at our electronegativity table, you should have your own electronegativity table. So nitrogen is going to have electronegativity of 3.04. So we'll write that up here. So 3.04. And hydrogen has a electronegativity of 2.20. And so if we look at the electronegativity difference between these two, right, we can see that nitrogen is definitely greater. And so the difference here would be, let's see, 1.16, it looks like. So the electronegativity difference is going to be, let's see, no, I'm sorry, not 1.6. So it's going to be 84. So the electronegativity difference here is going to be equal to 0.84. And so we can see that the 0.84 falls within this range here. So yeah, so it is polar covalent as suspected. And so since it's polar covalent, there's going to be a partial negative and a partial positive side. And so we got to remember that the partial negative side is going to be the side with the more electronegative atom, because the more the electronegativity, the more it's going to draw those electrons or attract those electrons in the bond towards it. And so it's going to have a partial negative. So we could put a partial negative here, right? So this is going to be partial negative. And so the hydrogen would then have a partial positive charge. So either delta negative, delta positive, same thing. Okay, let's go to nitrogen bonded to chlorine. Now, so we're going to look at the electronegativities differences here. Now, these two are closer together in the periodic table, so we would expect a smaller electronegativity difference, but we'll see and find out. So again, we have two nonmetals here, so we would expect this to be a covalent bond, not a metallic, I'm sorry, not an ionic bond. And so we would expect this to be either polar or nonpolar. So we'll see. Maybe it might be nonpolar depending on the electronegativity difference. So we'll find out. So again, nitrogen is going to have 3.04, and I think chlorine is 3.16. Yes, 3.16. So 3.16 for the electronegativity. And again, you can see that they're closer together. So the electronegativity difference between these two is going to be 12, 0.12, 0.12. And so you can see that 0.12 is less than 0.4. So it is indeed nonpolar covalent. So this one is polar covalent, and this one is nonpolar covalent. I can't spell today. Covalent. Okay, so because it's a nonpolar covalent bond, we're not going to apply the partial positive and partial negative because the nonpolar covalent nature means that they're being shared equally. So one side is not going to be more positive or more negative than another. Okay, let's go to C. Here we have calcium and oxygen. Calcium is a metal, oxygen is a nonmetal. So we would expect this to be an ionic bond because that's ionic bonds form between metals and nonmetals. So let's look at the electronegativity difference. So calcium, if we look up the electronegativity difference, if we look up the electronegativity of calcium, we get 1.00, and for oxygen, I believe that was 3.55 or 3.44. So here we have 3.44. And so if we take the difference between those two, so the electronegativity difference between those two is going to be 2.44. So 2.44, and that is well above the 1.7. So this is definitely ionic. Okay. So we're going to have a negative ion for the oxygen, which is a -2, and a +2 for the calcium. And finally, we got phosphorus and fluorine. So we'll see what that is. So based on the fact that these are non-metals, we would expect this to be a covalent bond, not an ionic bond. So it's a matter of deciding whether it's polar covalent or non-polar covalent. So let's take a look. So phosphorus has an electronegativity of 2.19 here. And fluorine, the most electronegative, has an electronegativity of like 3.98. Let me double check. Yes, 3.98. So 3.98. And so the electronegativity difference between these is going to be, let's see, we have 81 plus 98. Yeah, that's going to be an electronegativity of 1.79. Let me double check that. Yep. So this is the electronegativity difference. Oops. So the electronegativity difference is equal to 1.79. So you can see that it's a little bit above the electronegativity threshold of the polar covalent. So we might expect this to be ionic, but it is two nonmetals. So instead of ionic, we will opt for a polar covalent bond. So this is a polar covalent bond. And so we can apply the partial negative, partial positive. The fluorine is the more electronegative atom, so that's going to be the delta negative or partial negative charge. And then the phosphorus will have a partial positive or delta positive there. And so that, ladies and gentlemen, is how you use your electronegativities to identify or classify what kind of bond you have. And I hope this video was helpful. If you enjoyed this video, if this was helpful in any way, then please, by all means, like the video, share the video, hit that like button. Also, subscribe to my channel. And when you do, make sure you click the notification bell. Click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to go over and help you with, I would love to do that for you. If you have a topic you want me to go over, I would love to do that for you. Thanks for joining me and have a great day.